Okay, hello students. My name is Kamulegeya. I'm a teacher of mathematics. In this video, I'd like to talk about applications of trigonometry. Since in our first video, we were able to look at the ratios of trigonometry. Now in this case, we're going to see how we can apply the ratios of trigonometry in the real world. Since we say that this trigonometry work is a bit important in mathematics. Okay. Here on blackboard, you are seeing there are some drawings. There's this young lady here. This young lady here is looking at the building, whereby after looking at the building horizontally, it said to look at top, and he wants to go on top of a building. Now remember, to go on top of a building, use an elevator, meaning that this angle here, whereby he moves his eyes from horizontal part, moving to the point where he wants to go, we shall call it the angle of elevation. Reason being, we call it the angle of elevation because to go up the building, we use an elevator. We shall say this angle here, theta, we shall call it angle of elevation. Angle of elevation. Because to go up this building where this young lady wants to go, use an elevator. If you use an elevator, therefore, an elevator will take you up. Meaning that the angle where you move your eyes to go up, we call them the elevation, angle of elevation. Because to go up the building, use an elevator. Now, maybe this young lady you are seeing here, she managed to reach the top of a building. When she's on top of a building, she's looking horizontally. Suddenly, she decides to change her eyes to look down. On looking down, remember, when you're on a higher building and you look down, you feel depressed. You feel like you want to fall down. Is it okay? Therefore, shall we say the angle of depression. Because when you're on a very high building and you look down, really you feel like you want to fall down. You feel depressed. You feel like you want to get down. Meaning that this one we shall call it the angle of depression. Angle of depression. Angle of depression. Theta. Now, when you are down and look up, it's going to be elevation. When you are up and you look down, it's going to be depression. But you are seeing this angle here, angle theta and angle theta, meaning that the fact here is angle of depression must be equal to angle of elevation. It is a fact. You need to know it. Angle of elevation must be equal to angle of depression. Is it okay? Let me hope we have understood this concept here, because this concept here is going to be of much use when you are dealing with application of trigonometry. You need to understand what we mean by angle of elevation and what you mean by angle of depression. Angle of depression, when an element is up and it wants to get down, you go through angle of depression. Now, when an element is down and it wants to go up, it uses angle of elevation. Take an example. If you're a pilot and you want to fly an aeroplane, you fly an aeroplane at the angle of elevation because you take an angle so that you can fly and you go up. At the same case, if you're a pilot and you want to land that aircraft, when you're up in air, you look at the airport, you take the angle of depression so that you make sure that the aircraft can land safely. This concept is very important and applies in different aspects of mathematics. Okay. I'm going to dictate a question which you're going to try out, and we see how you can apply this concept of trigonometry. Okay, get where you're right so that I can read out this question. The question says, John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree. Together. And looks up. The angle from the ground to the top of a tree is 33 degrees. Find the height of the tree. Let me repeat the question once more. The question says, John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. the angle from the ground to the top of the tree is 33. In this case, 33 is the angle of elevation. And then they are saying, find the height of the tree. Now, in this question here, John wanted to measure the height of a tree without going directly to that tree to measure its height direct straight out. But he wanted to apply trigonometry to see if he can get the height of a tree by these simple concepts. Let's try out to do that number and you see how it works out. Look, if this is the tree, that's our tree, meaning that we are interested in getting this height here. The height of our tree. And John decided to move 100 feet. 100 feet out from the tree. John moves that distance. Then after moving that distance, he said to look up. By looking up, we are going to get this angle here. You are saying you want to measure this height of the tree, which you don't know, and this is a 90 with the base. John had moved 100 feet from the base of the tree up to this angle. Then when he reached this point here, he looked up through an angle of 33 degrees. And they want us to get the height of the tree. Now, last time I taught you a simple method you can normalize the ratios of trigonometry. Therefore, we talked about SOHCAHTOA. SOHCAHTOA can remind you this was opposite hypotenuse, adjacent hypotenuse, and opposite adjacent. Now, since we have our angle theta here, we say that if this is the angle, this one will be the what? The opposite. This one will be the adjacent, and this will be the hypotenuse. Now, in this case, we want to get the opposite and we have the adjacent. We come here, opposite and adjacent. The best ratio we're going to use is going to be tan. We shall say tan theta is equals to opposite over adjacent. In this case, tan theta is 33 is equals to opposite. Our opposite is h, which you don't know, the height. The last adjacent is 100 feet. It is 100. Now in this case, we are going to cross multiply. And cross multiplying, we are going to have this multiplies with that, so this multiplies with that. We shall have h is equals to 100 times into bracket tan 33. Now h is equals to, get your calculator and